Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 5A Paper 1 Code C&D Physics. Let's move to question number 1. In question number 1, a swimmer at one bank of a river at point A reaches at point B on the other bank of river and come back to the same bank at point C as shown in figure. The width of river is 12 meter. If swimmer always swims with minimum possible speed with respect to water to reach point C along path ABC, then time taken by swimmer for this complete journey is T0 seconds. Find the value of T0 by 5. So in the given question, the value of T0 is equal to the time taken from A to B plus the time taken from B to C. So I can write in this way: T0 is equal to time from A to B plus time from B to C. So it is given in the question that the swimmer always swims with minimum possible speed with respect to water. So when the swimmer swims along the path AB, then the resultant velocity of the swimmer with respect to ground must be along the path AB. So we can say that in that situation, suppose the velocity of river in this direction is VR, then the component of velocity of VR in this direction is VR cos 53 degree, because this angle is 53 degree, and the component in this direction perpendicular to line AB is VR sin 53 degree. So the swimmer must swim in such a way, must balances the perpendicular component of the velocity of the river to the line AB. So we can say that in that case, the time taken by the swimmer can be written as the length of this path AB, that is 12 divided by cos 37 degree, plus the velocity of the swimmer with respect to ground along the line AB, that is VR cos 53 degree. In the same way, we can write the time taken by the swimmer along the path BC. So in order to calculate this, the velocity of river in this direction is VR and this angle is 37 degree. So the component of velocity of the river in this direction is VR cos 37 degree and the component in this direction is VR sin 37 degree. So the distance of this length BC can be written as 12 divided by cos 53 degree divided by the component of the resultant velocity of the swimmer along path BC is VR cos 37 degree, because the swimmer swims in such a way that it cancels the component of the velocity of river perpendicular to BC. So if I solve this on substituting data, because the value of VR is 5 meter per second, it is given in the question. So this comes out to be 5 seconds and this also comes out to be 5 seconds. So the value of T0 is 10 seconds. In the question it is asked, we have to calculate the value of T0 by 5. So the correct answer for question number 1 is 2. Let's move to question number 2. In question number 2, a block of mass 1 kg is resting over rough inclined plane where the coefficient of friction is 1. The minimum force which is needed to slide the block along the inclined plane is F0 Newton. Find the value of 3F0 root 2 and it is given the value of G is 10 meter per second square. Let the force F0 is acting in this direction and the angle made by this F0 with this inclined plane is let theta. So if I take the component of this F0, then along this the force will be F0 cos theta and the force along this direction is F0 sin theta. Now if I take the component of the gravitational force, then mg cos 37 degree will act in this direction and mg sin 37 degree will act in this direction. Now it is given in the question, what is the minimum force which is needed to slide the block along the inclined plane. So in order to have the minimum force, the value of friction must be maximum and the friction is acting in this direction. So for the minimum value of the applied force, the friction force has reached to its limiting value and it is just sliding. So I can say that F naught cos theta plus mg sin 37 degree, that is 3 by 5, is equal to mu into normal reaction, and the value of normal reaction can be written as mg into cos 37 degree, that is 4 by 5, minus F naught into sin theta. So if I solve this, the value of F naught comes out to be mg by 5 into 4 mu minus 3 divided by cos theta plus mu sin theta. Now in the question I have to find out the minimum value of applied force. So for the minimum value of applied force, for F naught to be minimum, this expression must be maximum, and the maximum value of this expression can be written as under root 1 plus mu square. So writing the numerator value, that is 4 mu minus 3. Now if I substitute the value of m, mu and g in the expression, then this value comes out to be root 2 Newton. In the given question, we have to find out the value of 3 F naught root 2, so that comes out to be 6. So the correct answer for question number 2 is 6. Let's move to question number 3. In question number 3, a spherical bob is connected at one end of an ideal string of length L, whose one end is hinged about point O, so that bob can perform vertical circular motion inside an ideal liquid whose density is half of the density of bob. If complete arrangement is accelerating vertically upward with acceleration 2g, then minimum possible speed which should be given to the bob so that it just complete the vertical circle is v naught equal to under root 5n gl by 2. Find the value of n. So in the given question, the fluid is accelerating vertically upward. So if I see the free body diagram of the bob, then the buoyancy is acting in this direction, and the value of the buoyancy in this case is mass of displaced liquid. Then m can be written as volume of the bob, that is v, into the density of the bob, that is rho. So in that case it can be written as v into density of liquid, that is rho by 2, into g plus a, so that is equal to 3g. So it is equal to 3 mg by 2. So this is the value of the buoyancy in the case of the accelerated fluid. Now if I solve this problem in the frame of this observer, which is accelerating itself vertically upward with acceleration 2g, then in the frame of this observer I have to apply a pseudo correction on the bob. So its weight is mg and the pseudo correction is acting in this direction, so that is equal to mass into acceleration, that is m into 2g. So effectively if I write down the forces acting on the bob in the frame of this observer, then the tension T is acting in this direction and net gravity acting in this direction is 3 mg by 2. So we can say that the value of G effective is given by 3g by 2. Now in the frame of this observer, if it is given a velocity v naught, then in order to just complete the vertical circle, the value of v naught must be equal to under root of 5 into g effective into L. So if I substitute the value of g effective, so this can be written as 5 into 3g by 2 into L. So on comparison, we can say that the value of n is equal to 3. Let's move to question number 4. In question number 4, 3 point masses are connected by two ideal strings and complete arrangement is placed over a smooth horizontal XY plane. If mass m is given velocity v naught horizontally, then work done by tension on each mass 2m till just before collision between them is n mv naught square by 25. Find the value of n. So in the given question, I am considering this x direction and this is my y direction in the horizontal plane. So if I draw the positions of the 3 point masses just before collision, then the situation is like this. The mass m is here and it is moving in the vertical direction with some velocity vy, and the two other masses are something like this and their velocities are vy in this direction and let Vx in this direction. Since no external force is acting on this system, so we can say that from the principle of conservation of linear momentum in x direction, their velocities must be Vx and the direction I have shown. Similarly, if I apply the principle of conservation of linear momentum in y direction, then I can say that m into v naught is equal to 5m into vy. So the value of vy comes out to be v naught by 5. Now I have to find out the work done by tension on each mass 2m till just before collision between them. So the work done by tension is equal to change in kinetic energy of mass 2m. So that can be written as half into 2m into velocity of the mass 2m in the final situation and its square. So that is equal to Vx square plus Vy square, that can be written as V naught by 5 whole square. So I have to find out the value of this expression. So from the principle of conservation of mechanical energy, I can say that half into m into V naught square is equal to half into m into V naught by 5 square plus 2 times kinetic energy of point mass 2m. So that can be written as half into 2m into Vx square plus V naught by 5 whole square. So if I substitute the value of this from this equation, then it can be written as half mv naught square into 1 minus 1 by 25 into 1 by 2. So if I solve this, it comes out to be 6 by 25 m v naught square. So on comparison, the value of n comes out to be 6. Let's move to question number 5. In question number 5, a point mass m is connected at circumference of a uniform disk of mass m radius r. The disk is performing purely rolling motion over rough horizontal surface. If at an instant shown in figure, angular velocity of disk is 1 radian per second, then frictional force acting on disk at the instant is 37 by k Newton. Find the value of k. The value of m is 1 kg and the value of r is 1 Newton. Let the center of mass of the disk is moving in this direction with acceleration a and it is rotating with angular acceleration alpha. So if I see the acceleration of this point mass m, then a acceleration is acting in this way, alpha into r is acting in this way, and due to the presence of angular velocity, it have an component of acceleration omega square r. So if I write the friction force in this direction on this disk, then we can say that in the horizontal direction, the value of F can be written as m into a for the disk and m into a minus omega square r for the point mass. So that can be written as m into 2a minus omega square r. The value of m, omega and r are given in the question. So we have to find out what is the value of a. Since the system is in the state of pure rolling, so at this point we can write the condition of pure rolling. So a is equal to alpha into r. So we can say that this can be further written as 2 into alpha r minus omega square r. Now we have to find out what is the value of alpha. So in order to write the value of alpha, let this is an arrangement and the center of mass of this arrangement is somewhere here. If I am considering this point P about which I am writing the equation of torque, then this point P lies on the disk and this point P is the accelerated frame. So in the frame of this point P, this complete system is in the state of pure rotation. So I am writing the equation of torque about point P. So torque about point P is equal to I about point P into alpha about point P. So the position of the center of mass of this combined system is at this point at a distance of r by 2 and its mass is 2m. So 2mg is acting in this direction due to the gravitational force and since the acceleration of this point P is omega square r in this direction, so in the frame of this point P I have to apply pseudo correction. So that can be written as 2m into omega square r. So the torque of this forces about point P can be written as the torque due to normal reaction friction is 0. So 2mg plus 2m into omega square r, and the point of application of this force is at a distance of r by 2 perpendicular separation into moment of inertia of this combined system about point P. So the moment of inertia of the disk about point P is 3 by 2 mr square plus that of point mass is 2 mr square into alpha. So if I substitute the value of m omega r here, then the value of alpha comes out to be 22 by 7 radian per second square. So if I substitute the value of alpha in this equation, then 1 into 2 into 22 by 7 into 1 minus 1 square into 1. So if I solve this, it comes out to be 37 by 7 Newton. So on comparison, the value of K comes out to be 7. So the correct answer for question number 5 is 7. Let's move to question number 6. In question number 6, if 100 joule of heat is provided to 2 moles of an ideal diatomic gas undergoing the process Pt equal to constant, then work done by gas is given by 400 N by 27 joule. Find the value of N. So the given process is Pt is equal to constant. For the ideal gas, it can be written as P into Pv is equal to constant, or that can be written as P into V raised to the power half is equal to constant. So if I compare with the polytropic process Pv raised to the power x is equal to constant, then the value of x comes out to be half. Now we know that the molar heat capacity for the polytropic process is given by C is equal to Cv plus R divided by 1 minus x. Or if I multiply this equation with N into delta T, then we can easily say that the work done by the gas can be written as R divided by 1 minus x into N into delta T from the equation of first law of thermodynamics. Now I have to find out what is the value of this delta T. So that can be written as R divided by 1 minus x into N, and the value of delta T can be written from this equation Q is equal to N into C into delta T. So if I substitute the value of delta T, that can be written as Q by N into C. So the value of Q is given in the question. Now I have to find out what is the value of C for this polytropic process. So that can be written as C is equal to Cv. For the diatomic gas, the value of Cv is 5R by 2 plus R divided by 1 minus x, and the value of x is 1 by 2. So on further solving, it comes out to be 9R by 2. Let's substitute the data in order to calculate the work done by gas. So this can be written as R divided by 1 minus 1 by 2. N gets cancelled out. The value of Q is 100 and the value of C is 9R by 2. So if I solve this, it comes out to be 400 by 9 joule. So if I compare, then I have to multiply this expression with 3 and divide by 3. So on comparison, we will find the value of N comes out to be 3. So the correct answer for question number 6 is 3. Let's move to question number 7. In question number 7, a string of length L is equal to 10 meter fixed at both the ends, that is at x equal to 0 and x equal to 10 meter, is vibrating in its fifth harmonic. Phase difference between two particles which are situated at x1 is equal to 0.27 meter and x2 is equal to 6.27 meter is n pi. Find the value of n. So this is the length of the string, and this is my x equal to 0 and this is my x equal to 10. Since the string is vibrating in fifth harmonic, it means if I make the loops, let this is 2, this is 4, this is 6 and this is 8, then the string is vibrating in this fifth harmonic. The points which lie between 0 to 2 are in same phase, and let they are moving in upward direction, then all the points which lie between 2 to 4 are in same phase, but they are moving opposite to what the particles are moving between 0 to 2. So all the points between region 0 to 2 and all the points in the region between 2 to 4 are in opposite phase. Now in the given question, the value of x1 is 0.27, which lies in this loop, and the value of x2 is 6.27, which lies in this loop. Now the points lying between 2 to 4 and 6 to 8 are in same phase. So we can say that the particles situated at 0.27 and 6.27 are in opposite phase. So the phase difference between them must be equal to pi. So on comparison, the value of n comes out to be 1. So the correct answer for question number 7 is 1. Let's move to question number 8. In question number 8, consider the shown diagram. All pulleys, springs and strings are ideal. Springs having spring constant are shown in figure. If frequency of linear oscillation of mass m in vertical direction is given by this expression, then find the value of n. So let the given system is in equilibrium. So if I displace this block by displacement x, due to this displacement, let the extension in the spring k is x0, in the spring 2k is x2, and the spring k is x1. Then we can say that the value of x must be equal to x0 plus x2 plus 2x1. Now this k, this string, and this 2k are in series, so we can say that if x0 is the extension in k, then k into x0 must be equal to 2k into x2. So from here the value of x2 comes out to be x0 by 2. Similarly, if I am writing the relation between x1 and x0, then I can say that 2k x0 is equal to k into x1. So the value of x1 comes out to be 2 times x0. So if I write this complete expression in terms of x0, then it can be written as x0, x2 can be written as x0 by 2, and it can be written as 4 into x0. So on further solving, it comes out to be 11 by 2 x0. Now the restoring force acting on block of mass m can be written as k into x0, and the value of x0 from here can be written as k into 2 by 11 into x. So that is equal to mass into acceleration. So the frequency of a spring block system can be written as F is equal to 1 by 2 pi into under root k equivalent, that is 2k by 11 divided by m. So on comparison, the value of n comes out to be 4. So the correct answer for question number 8 is 4. Let's move to question number 9.